So what we did earlier, okay, is to solve the wave equation using separation of variable. Okay, so let's say we have, okay, consider two wave functions, y1 and y2. So these wave functions are given by the following. Okay, they both have the same amplitude. Okay, and then their wave equations are given by this, or wave functions are given by I kx minus omega t and e to the I capital Kx minus omega t. Okay, where k is equal to capital K is equal to small k plus some changes in k, and capital omega is equal to small omega plus some changes in omega. Okay, so this delta are small amounts. Okay, so by principle of superposition, another solution can be derived from this solution by these two solutions, wherein we can just take the sum of these two solutions. So this is y1 plus y2. Okay, so if we're going to add them together, we have the following. So this is a e to the I kx minus omega t plus a e to the I capital K x minus omega t. Okay, so this can now have a solution a. Then separating the exponents, we have e to the I kx e to the negative I omega t. Okay, plus e to the I capital K x e to the negative I omega t. Okay, we know that capital K and capital omega are given by K plus delta K and omega plus omega delta omega. We have a e to the I kx e to the I omega t plus e to the I kx e to the I delta kx e to the negative I omega t e to the negative I delta omega t. Okay, if we're going to multiply this by 1 and we're going to split the delta omega in half, we can rewrite this as e to the I kx e to the I delta k over 2x e to the I delta k over 2x negative e to the I omega t e to the I delta omega over 2t e to the negative I delta omega over 2t and e, okay, and this is negative, okay, plus this one e to the I kx e to the I delta k over 2x e to the I delta k over 2x e to the negative I omega t e to the negative I delta omega over 2t e to the negative I delta omega 2 over t. So this two equation, this 2 is actually equal to this. This 2 is actually equal to this. This and this terms are equal to 1. And these two terms are equal to 1. What we can see here is that we have common factors. This is common with this term, as well as this two terms is equal to these two terms. Okay? So that means our y can now be written as a times e to the I kx e to the I delta k over 2x e to the negative I omega t e the negative I delta omega over 2t times k times this and this. So this is e to the negative I delta k over 2x e to the I delta omega over 2t plus e to the I delta k over 2x e to the negative I delta omega over 2. Okay, so we just factor out the common factors. Okay, so rewriting this as e to the I k plus delta k over 2x minus I omega plus delta omega over 2t times e to the negative I delta k over 2x plus delta omega over 2 plus e to the I delta k over 2x minus, this will be minus delta omega over 2. Should be we're going to recall e to the negative I theta is equal to cosine theta minus I sine theta, and e to the I theta is cosine theta plus I sine theta. So that means this can now be rewritten as twice the cosine of the function. Okay? So this can now be rewritten as a e to the I k plus delta k over 2x minus, so it should be minus omega plus delta omega over 2 times cosine of 2 cosine of delta k x minus delta omega t all over. So this is your okay. You will notice here again, this is considered to be a complex function that includes cosine and dimension. This is a real function. So if we're going to look at the real part of the solution, okay, Okay, we have real part of y as a function of x and t will be equal to a cosine k plus delta k over 2x minus omega plus delta omega over 2t times 2 cosine delta k x minus delta omega t divided by. So this is the real part of the solution. If you're going to notice here, we have two oscillating functions. We have this oscillating function. We call this function as your oscillating term. So this is the actual wave. And this together with this form the what we call the envelope. If we're going to graph that, it would look something like this. This is your x. Okay, so this is your envelope term. It is a sine cosine function. So it would look something like this. But this is not your function only, because this is only the envelope. Okay, this is the envelope, and this term is actually okay. So this is actually just an envelope that restricts your main function. So this is your main function, and this is your main function. Okay, so this is your main function. So your assignment, plot this function at time equal to, okay, using any software.